of you have been in email contact with Roya, and today's Roya's birthday.
Oh!
It's very, very, very pleasant to be taken care of by email, by you, Roya, I'd like to say. And I want to offer that we sing you happy birthday. Is that okay for you? So I'll give you the... right? We'll go like, happy, happy. Okay, ready?
Yeah.
3, 2, 1. Happy birthday to you. Happy birthday to you.
Happy birthday, dear Roya. Happy birthday to you.
Would you like to say something?
No. I'm already blushing and I don't like
So today and tonight, I'd like to talk about love and fear in the lab, which is an exploration of the emotional aspects of doing science. And to start off, I'll do a few songs because we'll talk about matters of the heart. I won't use PowerPoint. I'd rather try to use the guitar as a way to convey emotional information. So I'll do a few songs. And let's start right away with a song about being scooped, which is the experience where you work, you discover something, and somebody else publishes it before you do. And it's a blues song, of course. And I'd like to ask you to be backup singers. Right? And your text is scoop, scoop. And it sounds like this. I'm scooped again. Scoop, 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 scoop. So let's try it. Okay? Let's try it. It's a big room, so let's see if we can hear you. I've been scooped again.
Scoop, scoop.
Good rhythm. Let's do it again with twice the amplitude. I've been scooped again.
Scoop, scoop.
I'm in the lab, check out what's on the slab. I'm running gel after gel, it makes my life a real hell. I'm a receptor, lizard, I'm a lying wizard, roaches, draping paper, gonna send to science. I went down to the library just to check out the journals of February. I've been scooped again.
Scoop, scoop.
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 Oh, Mama, can't you feel my pain? Heavens help me, I've been scooped again. Now I knew every flagella, yeah, I knew it real well. I could talk to the seller, cause I speak salmonella. Every mini prep got my full attention. Oh, to publish first, that was my intention. I'm down to the library. This was my postdoc in 1999. It was still a library. Just to check out the journals of September 3. I've been scooped again.
Scoop, scoop.
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 Oh, Daddy, can't you hear my pain? Heavens help me, I've been scooped again. Thank you for backup singing. Very good rhythm here in Cuba. Being scooped feels bad, feels terrible, kind of shocking for a while. How many people know somebody who's been scooped? So I don't know how common it is, but it definitely adds to our fear, for example, to tell other people what we're working on, which is no fun since we came to science to talk about our ideas and to hear other people's ideas. It's a fear that can affect our behavior. And I don't want to talk about scooping in particular, but about why is it that in science we don't have forums like this where we can talk about the emotional and subjective things that happen in science. And just to give an example, when I started my lab in 1999, very ambitious, I wanted to succeed, my parents wanted me to succeed, my colleagues, and I walk into this whitewashed new lab, and I look around, and it feels like the ceiling is falling on me. I can't breathe, I have a panic attack. Because I realize I don't know what to do now. I mean, I studied thousands of hours of physics, biology, but not 1 hour about how to mentor, how to can go into the unknown together with students, how to interview. I would just talk. I was so desperate. I would just talk. So I didn't see who the students were. And I got some people who didn't fit with me or with each other. They started fighting. And so one person would say, "Get him out of my office. I can't stand anymore." He said, "Get her out of my office." And I said, each person said, "Yeah, you're right. Yeah, you're right." Without knowing how to get them together to talk or understand what the needs are. Then having to fire someone who said, "I can't sleep at night. Can I do this? Can't I do this?" All this white hair started then. Many things like this. Also, as a graduate student, when I got stuck and I felt like I'm not worthy of being a scientist because I'm stuck. I'm not like Einstein or Newton that never got stuck. Because you only learn science in a series of progression of steps from question to answer. And it's so different like that. The experience of research is being stuck. And so I started looking for knowledge about the process of doing science and principles. And it turns out that it exists. There's a lot of things to learn about how we communicate from fields like education, communication, improvisation theater, which is my hobby, how to go on stage and make a scene without knowing what to do. It's like going into the unknown in science. And you basically prepare the actors to stay comfortable in the unknown. That's what you do in improv theater. And so there's a lot of knowledge, and my lab became very enjoyable, and also I think the science got much better because of these ideas of how to work together, how to help people interact, etc. But we don't teach ourselves this in science. And make a metaphor. When we buy a microscope, we read the manual, we get the best optical table, the filters for it to work optimally. But when a new person comes into our group, what do we teach ourselves about the conditions needed to have a person reach their full potential as a scientist in a community of others, also groping, like this, failing all the time? We don't teach ourselves. And this leads to a lot of problems. So I guess my premise is that adding more discussions, workshops, sessions and conferences, etc., about the emotional subjective aspects of science will make science, our well-being better, and also the bottom line of science better. That's the idea. Now, why is it that in science we don't discuss this emotional subjective aspects? It's not by chance. Sociologists looking at science say that it's because of values. It's because we have a myth in science that's causing us problems. I want to tell you about this myth. So in science, we want to discover knowledge that's objective and rational. That's not a myth. That's the wonderful thing about science. So we want to discover knowledge that's objective and rational. Can you see this, what I'm writing? The myth is that the human being getting this knowledge, and the process of it, is also objective and rational, exclusively. Like Mr. Spock, if any of you know who this is now. I grew up in the 20th century. But being human beings, when we label something as objective and rational, we automatically label the other half, the subjective and emotional. Subjective and emotional. We label this as non-science, anti-science, or threatening to science. That's because we're human beings. When we label something as science, we label the rest of it as non-science. And therefore, we don't discuss it. We don't teach it. It's like a profession. It doesn't discuss its process, its emotional aspects. But people doing science usually recognize that doing science is not only hypothesis testing, but has to do with all of our humanity. For example, one of the most important things about being a good scientist is how to choose a good problem, what to work on. And that's an emotional choice. You're curious about something. That's emotional. You wonder about something. You're bothered about something. You're angry about something. You don't agree with something like that. Is emotional. It's like you're like a resonator that's tuned to resonate with something in nature. That's because of you. You find something interesting, beautiful, true. And every person has their unique resonator. That's what we bring to the table as scientists. No computer algorithm can tell you what to work on. That's an emotional choice. So I want you just to start the conversation. I'd like to ask you to say what you think are skills that are essential for being a good scientist, and that lie in the subjective and emotional half of the whiteboard.
When I first started my lab, I made everyone really think hard about what their spirit animal was. That, I think, really helped.
Spirit animal. Yeah? Please shower you. Yeah.
I think you need good communication skills, and that requires empathy with the person that is in front of you.
Good communication
And then empathy.
and empathy. And
Intuition.
intuition.
Optimism.
Optimism because of the difficulties we face, right?
Optimization.
Creativity.
Yeah.
Obsession, yeah. Obsession.
Yeah.
Dreams.
Because the data doesn't speak for itself, right? There's a lot of stories that we tell from the data. And
Dreams.
what?
Dreams.
Dreams, yeah. There's something called night science. Jacob talked about day science and night science. Huh? Passion. Yeah. These communication skills, like listening, it's extremely important. Like, for example, a good way to make enemies is to collaborate. Have you noticed? Not to collaborate skillfully. Collaboration is one of the most difficult, for science now relies on collaboration. But collaborating well is very complicated skill. For instance, a lot of problems are a lack of communication. So do you talk in advance about what can happen? What are the contract? What's the rules? What's our agreement? Or some people who are away from each other start going off in like directions without telling the other person. And just communications can solve a lot of problems here. But again, we don't teach ourselves how to collaborate usually. I mean, does anybody have a workshop on collaboration? Yeah.
Nope.
So, spirit animals, yeah. Okay, so we can agree that science has a kind of culture, with a cultural myth, which doesn't align with our actual experience of doing science, but it really affects the decisions made in science. Well, what to teach, for example, how your building looks like. And so this discussion has three parts. The first part is, you can say, science has a culture. And the second part is culture can be changed. Before we start that, I'll do another song. And this song is to remember someone who had a critical emotional role in my career as a scientist. He's called Mike Surratt. When I was a postdoc in Princeton, he was a postdoc in the lab next door. And I came, he had patience for every question. Why is there like sodium in this buffer, or whatever it is? He would tell me, he kept me from quitting science a lot of time. He didn't have to do it, he wasn't my mentor. He just did it. And so if you have someone like that, you can think about them when I sing this song, or have some person like that. So the music by Leonard Cohen. Mike takes you down to a place by the centrifuges. It's your first day in the lab, and you don't know what a centrifuge is. He hands you precious flasks, and you drop them, and they shatter. And you look at him quite meekly, but he says it doesn't matter. They were only the controls. And he gives you of his buffers, and he gives you of his strains, and you wish you had his genome, or at least you had his brain. Now I came to him one morning, an idea had been forming. My transformants weren't transforming, and my swarmers were not swarming. I said, Mike, I'm a failure. I'm gonna work at Lord and Taylor's. I think I'm quitting science, but he says, nah, don't be hasty. You see science like the cafeteria. Sometimes nasty, sometimes tasty. And he soothes you so discreetly, and you trust in him completely. And your mind has been freed, and you know that somewhere, something will succeed. Now Mike is packing his papers in a folder. There's a knapsack on his shoulder. His pipette is in his holder. And as he leaves the floor, the shakers all stop shaking. The columns all run dry, and the autoclave stops baking. It'll never be the same. And you know that you must keep him, or at least that you must clone him. And you know that you will miss him, and you know that you will phone him all the time. Mike takes you down. How many of you have someone like that? And somebody willing to mention who the name? That person? Huh? Charlie, and
Charlie Strauss.
and what was his relation like in the hierarchy of the lab? Or?
He was doing a sabbatical with Dave Baker, and Dave Baker was a very spacey dude, and then Charlie would come in and teach you how to, what a quaternion was.
Great. So it was a sabbatical visitor, and he played this role for you when you were.
He was pretending that he was a student. He liked to
Pretending that he was a
take him
student.
drinking, and then he would teach us math.
Okay. Good. Can you,
My PhD advisor.
huh?
Yeah.
Can you say like one word about how was it? What was-
Basically, he always listens. He always listened whatever, as you said, whatever downfall I had, and I don't know, just say it's gonna be okay or something.
What's his name? Or her?
And Kunihiro.
Kunihiro?
Yeah.
So I think these people really critical role in science, but okay. So culture can be changed. It can't help but change. It's changing all the time. And the way culture changes is well researched and understood. It has to do with the way people talk and what they talk about and what they don't talk about. Just to give an example, 100 years ago, women couldn't vote. And, everybody seemed to agree. You could read in the newspapers, women are good in the kitchen, in the home. It's dangerous to let them vote about wars, important things, right? It's now 100 years to World War I, 1914, right? And everybody seemed to agree, except for some that didn't. And after a few generations of struggle, they got the vote for women. Now, people don't change. Right? There's still people with chauvinistic opinions. But what you talk about changes people's behavior. It's unthinkable now to say, take back the vote for women. That's not something you can entertain anymore. So what you talk about changes the way people behave. And in science, we're really good at inventing language like words like I'm trying to think of something that's called what?
Repressilator?
Repressilator. We're good at creating cultures, teaching language, teaching concepts. That's what we do. So we should have no trouble in creating the language we need to talk about the emotional and subjective process of doing science. So we can talk about it, so that we can eventually change our systems, how we evaluate, promote, etc., more aligned with our values. But we don't talk about it now, and we get hijacked sometimes. And so I'd like to give an example to make it concrete about words. Okay. So a lot of times when I do this talk, I talk about the cloud. I want to know who's already heard about the cloud here? Cloud research. Oh, that's all. Who saw my TED talk? Okay, so maybe I should do it because I thought a lot of you knew about it already, and I wanted to do a little workshop on motivation. What is motivation? I can do that too if you want. So let's just do the cloud. So here's one word that was transformative for me as a mentor. It has to do with the mental schema, what our prediction is, and what it means to do research. So you start to do research, you're a new graduate student or something. So as human beings, whatever we do, we build a prediction before we do it. So if I want to touch this guitar, for example, before I even move my hand, my brain already builds the beginning of the trajectory of all the muscles. It's a schema. And if the schema doesn't match reality, it creates this shock called cognitive dissonance. It makes us kind of feel like the earth is shaking, something's really wrong. So your schemas had better be as accurate as possible. And what's our schema about research? So if you believe the way papers are written, or the courses are taught, then you're liable to have this schema. If A is the question, B is the answer, and research is a direct path. The problem is with the schema is that if your experiments don't work, or your student gets depressed, it's perceived as a cognitive dissonance. That's not the way the world should be. And this creates a lot of additional stress and problems, not only the frustration. So I teach my students, everyone who comes to my lab, a different schema that I think is more accurate. So A is the question, B is the answer. You start going, and then experiments don't work. And they don't work. 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 Until you get to a point linked with negative emotions, where it seems like your basic assumptions aren't valid. It's like somebody pulled the carpet beneath your feet. Very disorienting. And the word that we use for this is the cloud. The cloud of research. And you can be stuck in the cloud for a distribution of times that has a long tail. It could be a day, a week, a month, a year, a whole career. You die. You're reincarnated as a scientist. Still in the cloud. Again, another career, until you somehow break the cycle. But if you have enough support, then sometimes in the materials at hand, you can see a new answer. Let's call it C. And you decide to go for it. Okay? And then experiments don't work, but you get there. And then you publish a paper, A-C, which is a very good way to communicate. We talk about good communications, you tell the story, etc. As long as we don't forget, as a community, as a culture, the path that got us from A to C, looks like this. Now this cloud is an inherent part of our craft, doing research. Because it stands like a guard at the boundary here between the known and the unknown. Because in order to discover something truly new, at least one of your basic assumptions has to change, otherwise it's not new. That means as scientists, we try to bring ourselves every day to the boundary between the known and the unknown, and face this uncomfortable position of being in the cloud. That's what we do. Now, you can notice they put B in the land of the known. It's like the hypothesis in our NIH grants, or how do you call it? When you write your PhD, you have to hand in your
Research proposal.
research proposal. It's very important to have a good B, because without it, we can't get going. But C is almost always more beautiful, important, and fruitful than B. And that's why we do research, is to get this C, and bring it back to the land of the known. Now, as a mentor, students in my lab come quite often and say, Uri, I'm in the cloud. And I say, great, you must be feeling miserable. But I'm kind of happy, because maybe we're the boundary between the known and the unknown. Finally, we're at the cloud stage. And then I know what to do as a mentor, because there's a tendency when somebody's stuck like that, for mentors, to ignore them and to turn to the more successful projects, or to open up that box you got from Sigma, which has the whip you brought from Sigma, and apply some psychological pressure. But in fact, remember, research in psychology shows that if you're feeling fear, your mind narrows down to very safe paths of thinking, conservative paths. In order to get out of the cloud and explore more risky or creative paths, you need other emotions. You need solidarity and hope to make this curiosity possible. That means, as a mentor, my job is to supply that, whatever that means to the student, because different people have different meanings for that. And it just helps me a lot to remember what to do in this situation, because I have a word for it. I have a word for it. So, how many of you have ever been in the cloud? The majority. And I'd like to hear from you, just to hear from you, how this resonates with your experience.
Miserable.
Miserable. Yeah.
I like it in the club.
You like to be in the cloud?
It's refreshing.
It's refreshing.
You try really new creative paths like C, D, F, each of which is really preposterous. But
There's a lot of C, D, and F that could be preposterous, but you enjoy it. What helps you get out of the cloud?
luck.
Love.
No.
That's stepping away. Stepping away. Yeah. So I want to emphasize that for many people, this is very individual. Some people working more and more and more is the way. For many people, taking a vacation, for example, I would say a well-timed vacation is part of the scientific method. You can quote me on that. And why is that? Why does stepping away help?
Perspective.
Good perspective. There's this theory of creativity that says that if we're stuck in one plane of associations, when we go away, we enter another plane of associations, and sometimes those planes intersect at a point where there's a new solution. And the story about that in our culture is Archimedes, the Eureka moment. You know the story of the Eureka? It says Eureka because the king asked him to calculate the volume of the crown to see if it's made of pure gold. He had to know the volume because he knew the specific weight of gold, right? And he tried all the geometry, all the triangles and stuff he knew, and couldn't figure it out. He was very frustrated. So he said, "I'm going to step back and go to the spa and have a spa vacation." And he entered the world of the spa, this association, you know, the candles, the music, the water, the aromatherapy and stuff. And then he got into the bath, and like all of us, like every person, you know when you get into the bath, the water rises, right? But because of this problem in the back of his mind, he realized the water rises according to the volume. And then he said, I don't know how to get the volume of the crown. So that's why stepping back is, I would say, part of the scientific method. What else helps?
Talking about with other people.
Talking about with other people? Yeah. So what would you say are the properties of this person, let's say you want to talk to in the cloud?
Mostly someone who listens.
Somebody that
Know a
listens.
little about science is good.
Someone that listens and maybe also knows about science. Other idea? Yeah. So listens. Just listens. It's amazing. It's a really important word, I think, for scientists. It's listens, because why is it somebody who listens can help you get out of the cloud?
You talk through it.
Yeah. So this is a very interesting thing, again, about listening. So listening, it's called active listening, which is the act to make the other person say more, keep talking, ask questions, keep talking, tell me more. I'm fascinated by your. The thing is, you talk about your problem. You talk, tell me more. You talk, tell me more. You talk. The voice ends. Then the second voice inside you starts talking, because this second voice has no one to listen to it, not even you. And it comes out. And sometimes the second voice has a different point of view. So a lot of times the solution is inside you. Sometimes you can talk to an expert. A lot of times the solution is inside you, but someone who listens can draw it out. That's why, so I appreciate so much you said someone who can listen. Okay, so this cloud is very interesting for me to talk about it and to recognize different ways to get out of the cloud. I think we can research it. The last part, unless I'm putting an option 4 of this, which is a workshop on motivation. What is motivation? So I think what I'll do is we'll end after this 3, but then anyone wants to stick around, I'll do this also. How to demystify motivation. Why is it sometimes you feel unmotivated? What you could do about it? Either as a professor when you feel burned out, or as a graduate student where you don't want to come to work in the morning. Yeah. But before that, I want to talk about how you can change or begin to change the culture of science at your institution. And I'll tell you a protocol that's been reproduced over 20 times in different places. Before that, another song. This song, it's called Decision. And it happens to be 75% of the time. Dear authors, we have now heard from 3 referees whose comments are attached below. As you will see, they have raised concerns about your interpretation of the facts of choice of all systems, your references, and the style of your prose. Oh yeah. Referee number 1 says the topic is interesting, the results are incorrect. Referee number 2 says the results are correct, the topic isn't interesting. Referee number 3 suggests 14 additional experiments, although tangential to your main point would be nice to have. Oh yeah. As a result, we regret that we cannot offer publication at this time. Please know that we value your work and would like to see more of it in the future. At the same time, we remain committed to the high standards of the archival journal of upper cavity research. So, of course, peer review is essential. It always improves and saves us from some pretty bad errors. There's also something like a certain, how do you call it, cycle of abuse of reviews that you can recognize are not and constructive. We all can recognize what reviews we'd like to get. It's not published immediately, but somebody who sees the potential of the paper and some reasonable way to address some. It doesn't have to answer all the problems, etc. How many of you got a course as a graduate students how to review a paper? Like part of your education. So usually when I ask this, it's almost no one. We do have journal clubs where you kind of take out your dagger and try to prove why the author is wrong, which is not the same way as teaching ourselves how to write reviews, which has, I call it the feedback pita. The pita is the idea that we're here to remember there's a human being on the other side, and we're here to help this paper reach a good potential. And then plus means seeing the potential of this paper, and delta saying constructively what can be improved. So that's kind of a schema. Okay? So I think we can teach ourselves, it's part of teaching ourselves, like what a hydrogen bond is, how to review. So that's just a way to change culture. But how can you change culture at your institution? So there's many ways. And the story that I'd like to tell you is that in Israel, at Weizmann we hired in a certain year, I think around 2007 or something like that. We hired 17 new faculty members in one year. Yeah. And they were already of this generation that doesn't want to. They want to be. They wanted information, how to be a good mentor, how to all this stuff. So they went to the deans, and the deans were very good. They got them together. So it was the first time that all the new faculty got to see each other. That's interesting. And then they said, we have this management consultant from business, and they'll give you a kind of management workshop. And this was didn't work at all. It was kind of disastrous because they showed them the organizational chart. Let's see, this is the president, this is the vice president. So when you have to do an experiment, who do you ask? The president, the vice president? It doesn't match. But they kept looking, and they found this firm in Germany that does workshops for scientists. They work in EMBO. Has anybody ever done this EMBO workshop, leadership management? Yeah? How was it?
Great.
And you? Was it useful? Okay. And they brought them to Israel. The difference was that I guess you guys did it with people from other countries? Did you? Yeah? You traveled to Heidelberg? Or? So they brought them to Israel, and all 17 from the same institution did this workshop, which presented kind of graphical ideas like this, and they did a lot of work on their own in small groups, with communication skills, etc. And they were quite skeptical in the beginning, but after this, they recognized it was probably the most useful days of their career so far. And they went the next week, they said, let's meet and talk about what we learned in this workshop. And instead of 17 stories, they had time for just one story. Very talented student, motivation went down to do. And they got so much solidarity and hope, like I said. Solidarity because there were people who were in the same boat. So if you're a graduate student, for instance, in Vanderbilt, now 2015, or you're a non-native English speaker in MIT, whatever, nobody can understand you like other people in the same situation. So that's solidarity. And hope is because they tell a story, somebody else has a story that happened to them, and you can see what worked. That's hope. So solidarity and hope, that's the way to combat the helplessness we feel sometimes if we don't like the culture of science, right? And it creates a space for people to talk. And to develop the emotional aspects of being a scientist. And this group of 17 kept meeting every 2 weeks and formed a peer group. So this is not a therapy group, because nobody's sick. It's a peer group that basically tries to empower each other and to actually generate ways to change the culture of science at Weizmann. Now some of them are like department heads, so they can really change systems. And peer groups like this are a lot of fun. They're not for everyone, of course, but for people who need this vitamin of other people who you can talk with and trust, it can be an essential vitamin, I would say, for being a scientist. It could be graduate students, postdocs, female postdocs. We know we have invited so many peer groups. We have biology students after their midterm and before their final. We have many. And they form, they disband, and people come, etc. Usually size 10 is a good size. And we meet over lunch, etc. So you're very busy, you have very busy lives, and for most of you, it's not the right time now to do anything else. I'm wondering who here might be interested in getting more information on how to start a peer group. And you raise your hand and I'll send you one email with some information. Yeah, so let's see, is it 10 people? That's good. 11, 12. So after this, you come and we'll get your email, and I'll send you some stuff, and we can discuss what happens with the peer group, etc. And okay, so we covered this material today, class, and now we're going to end. Or how many of you want to stay for a workshop on motivation? It lasts like 30 minutes. So I'll do it. But before I finish this first part, I want to do one last song. So I want to ask you, what topic to sing about?
What topic on what?
I'd like to do a song, and I'd like to ask you what topic. Like I sang about Mike's Soret about. I sang about a review, like a letter, like a decision letter. And so maybe you'd like me to sing about some topic in science.
Overnight flights.
Overnight flights. Okay. Reproducibility. What else?
How it felt when you became a PI?
How it felt when I became a PI. So overnight flights, reproducibility. How it felt when I became a PI.
Making decisions.
Making decisions. Okay. So I'll try to improvise a song. It's difficult to know what will happen. Would you like the chicken or the pasta this evening? Oh, I woke you up? Sorry, you can go right back to sleep as I fold back your tray. You must be one of those scientific tourists on her way to Hawaii. Like every year this time of year, we see you go by. This is Q-Bio number 3. Is not like Q-Bio number 2. Not exactly, anyway. There's a 13% mean relative error between these year-to-year repeats. But it's close enough because there's something about this meeting which is not like every other meeting. Have you noticed? There's a little bit less kind of feeling of just a small cog in a big machine. Do you agree? Like more people talk to each other, students ask questions, for example, not only PIs. Why is that, do you think? In Cuba, Hawaii? Is it because of Hawaii, the palm trees around? Why? Is there a good feeling in this meeting?
Beer is good.
Huh?
Beer is good.
Beer? I think it has to do a lot with the intentionality of the organizers, actually. Like reflecting back on Galit's first words, the first thing we heard here. Like we primed what's important here, right? Like, do you remember what she said? Huh? What do you remember? Does anybody remember?
And it'll be a women's only conference.
Oh yeah.
Women's Only Conference by 2000.
We can
That's
split an
nice.
island in two.
What?
We can split an island in
We
two.
can split an island in two, yeah, but we're going to land in 30 minutes. The captain has turned on the fasten your seatbelt sign. There's a rosy sunset sunrise through the window. It's the end of the overnight flight. Okay, so I guess at this point, I'm going to turn to motivation. It's not such a. So I guess I don't want to keep those of you that don't. If you want to leave at this point, it's fine. Don't worry about it. And those of you that stay, so I'm going to turn my back and erase the whiteboard. You can creep away.